Good afternoon, class. We are looking at College Algebra, Chapter 8, Analytic Geometry, here Section 8.2, Hyperbolas. So we covered circles, ellipses, and now hyperbolas. The objective would be to determine general and standard form of equation of the hyperbola and graph hyperbola with centers at the origin. Recall, here's the definition of a circle. A circle is the set of points in a plane that are the same distance, called the radius, from the fixed point called the center. When it's centered at 0, 0, the equation is x squared plus y squared equals r squared. When it's centered at h and k, x minus h quantity squared plus y minus k quantity squared equals r squared. An ellipse is a set of points in a plane, the sum of whose distances from two fixed points is a constant. The two fixed points are called the foci. Each is a focus of the ellipse. F1 and F2 represent the two foci of an ellipse. And the distance PF1 plus PF2 is fixed, and it's equal to 2a. The equations are as follows: x squared over a squared plus y squared over b squared equals 1. X minus h squared over a squared plus y minus k squared over b squared equals 1. If a is larger than b, then c squared is a squared minus b squared, and if b is larger than a, c squared is b squared minus a squared. In other words, if it's elongated along the x-axis, the a is larger than b. If it's elongated along the y-axis, b is larger than a, b, c follow Pythagorean theorem, and it depends on whether a is larger or b is larger. And now hyperbolas. A hyperbola is the set of points in a plane, the difference of whose distances from two fixed points called the foci is a constant. For every point on the hyperbola, the difference m minus n is the same constant. This difference, if you pick a point, pf prime minus pf, or pf1 minus pf2. A hyperbola has two vertices. The vertices are the points where the graph crosses the x or y axis. When it opens sideways, it crosses the x-axis, and the x-intercepts, if it's centered at 0, 0, are considered the vertices. Center. The point halfway between two vertices is the center of the hyperbola. The line through the vertices is called the transverse axis. X squared over a squared minus y squared over b squared equals 1. It's similar to equation of an ellipse, but we have a negative here. And in this case, c, this distance, is larger than a, which is this distance, and b, which is this distance, and therefore it will always be a squared plus b squared equals c squared, whether it opens sideways or up and down. So as we look at this line is called the transverse axis. This is called the conjugate axis. Vertices, center, foci, focus 1, focus 2, and here's the distance m minus n that was discussed here. If it opens up and down, here's the center, here's the vertices, and the foci are located, in essence, you can think of inside the hyperbolas. Over here would be inside here and here. Over here would be here and here. And if it happened to have a transfer axis, which is neither horizontal nor vertical, on that transverse axis, you can find the vertices as well as the foci. All right. Graph hyperbola center at the origin. The equations are x squared over a squared minus y squared over b squared equals 1. Here's how it looks like. The hyperbola with the transverse axis along the x-axis. So here the vertices, this distance is a, this distance is b. Hyperbola centered at origin. Vertices are at minus a0 and a0. The transfer axis is along the x-axis. And the foci are inside along the x-axis as well. The asymptotes that will help us graph have the equations y equals b over a times x and y equals negative b over a times x. Now, y squared over b squared minus x squared over a squared equals 1. If it opens up and down like so, I like to keep the a squared under x squared. In some texts, they don't. If you keep it the same, this equation remains the same for the asymptotes. If you don't, this will change. That's why I like to change it in, I like to keep the a squared under x squared. Notice in this case, the coefficient of x squared over a squared is positive. In this case, the coefficient of y squared over b squared positive. And therefore, they have the same set of asymptotes. Now, this one, the vertices are located at a0 minus a0. In this case, the vertices are located at 0b and 0 negative b. So hyperbola centered at origin, vertices 0 negative b and 0b. Transverse axis is along the y-axis. Now, what you are looking at, this rectangle where the length in this case is 2 times b and the height is the length is 2 times a, this distance is a, 2 times a, and this distance is b, so the height, if you will, or the width, if you will, is 2 times b. This is called the fundamental rectangle. And what happens, with the help of a fundamental rectangle, we can graph the two asymptotes. When that happens, the location for here is a comma b. For this one is a comma negative b. For this one is minus ab, and for this one is minus a minus b. So, in short, x squared over a squared minus y squared over b squared equals 1. If we are looking at a parabola that opens sideways, otherwise y squared over b squared minus x squared over a squared equals 1 if it opens up and down. If we keep it in the same format, the asymptotes will remain unchanged, plus minus b over a times x. And this formula, a, b, c, follow Pythagorean theorem. And in the case of a hyperbola, c is always greater than both a and b. Whereas in ellipse, sometimes a is larger, sometimes b is larger. Terminology. Two hyperbolas that have the same set of asymptotes are called conjugates. So these two are called conjugates. All right, so we have the hyperbola, and we want to look at, again, reminding you of the fundamental rectangle and so forth. I want to look at some proofs. For example, if you look at this equation and you solve it for y squared, which means you're going to take this one to the other side and subtract x squared over a squared from 1 and plus minus. I'm going to leave it for you to solve it in this format. So I think it's very easy to get to this. So what happens is that if x is very large in the sense of an absolute value, that means because it's being raised to the power of 2, the absolute value of x is large, whether it's large on the negative or positive side, in an absolute value sense becomes positive, becomes large, and compared to a squared becomes so large that for all practical purposes, minus a squared becomes nothing compared to x squared. And this expression of x squared minus x squared approaches x squared. This is the concept known as limits. We will discuss it with more details in later courses. So in short, when x is extremely large or extremely small, then the x squared becomes so large that minus a squared has no meaning. So what happens? We get plus minus b over a, and square root of x squared becomes x. So that is the equation of asymptotes, and that is the definition of asymptotes, which means when x goes towards infinity, this way, x becomes huge, the function, the graph tends towards the asymptotes. When it becomes extremely small towards negative infinity, the graph tends its asymptote as well. Also, the difference between the point P and F prime and P F is either 2a or minus 2a. This is the point I'm going to look at. And the reason it's plus minus 2a, depending upon which one you take as the focus, you may look at pf minus pf prime or pf prime minus pf. In essence, the absolute value of that. So it could be positive or could be negative. The way this one is taken, since this is larger, then this one will be positive 2a. So the proof is very simple. Remember, by definition, this distance is constant. So if you pick any point, for example, if you pick this point, v f prime minus vf has the same distance. Because if you pick any point on the graph, you pick this point, for example. You pick this point. And again, the reason we go with plus minus 2a, or sometimes we go with an absolute value, because it depends which one is positive, which one is negative. So vf prime minus vf. As you can see, this graph is symmetric with respect to both the x and the y-axis. And so with that being the case, vf prime minus vf is the same as vf prime minus v prime f prime. This distance is vf, is the same as this distance, which is vf prime. Let me go with the green one. This distance, everybody, is the same as this distance. And therefore, v f prime minus v prime f prime becomes this distance, v prime, and since this is at a0, this is at minus a0, this distance must be 2 times a. So believe it or not, that's the proof. And as I mentioned, a squared plus b squared follows Pythagorean theorem. C is always larger than both a and b. This distance is a, and it may be easier to see. This distance is a, this distance is b, and f is somewhere here. This distance is c, which is larger than both a and b. All right, we're going to continue with the proof as follows. We mentioned that the distance from this point to F, we can follow the distance from here. Remember, the difference of distances is 2a. So we are going to look at PF, which is x minus c quantity squared plus y minus 0 quantity squared gives you that. And we're going to look at P f prime, which is x minus negative c, which makes it x plus c squared, and y minus 0 squared. And we know their difference adds up to a constant. And we showed the constant is 2a. So we are looking at this. This has a negative sign. We move it to the other side, everybody. Becomes positive. We are going to raise both sides to the power of 2. So this simply comes out. This becomes 4a squared. Then 2 times this one and that one. That means 4a times the square root, and this comes out. So again, this comes out. This becomes 4a squared. 2 times the product of these two is 4a times this, and this comes out. All you have to do is square, simplify, and collect like terms. So this simply becomes x squared plus 2cx plus c squared plus y squared. This doesn't change. This doesn't change. This becomes x squared minus 2x plus c squared, and this is just y squared. Now, we looked at both sides. We notice we have x squared identical. We don't have to move them. We just get rid of both. We see both sides have c squared and y squared identical. We don't have to move them. We get rid of them. And then this one, we are going to keep it unchanged. This one, we'll move it. And we notice we can get rid of the 4. Both sides. That makes it easier. We have to square it again. So this is c squared x squared minus 2acx or 2c a squared x and plus a to the power of 4. This becomes a squared, and this comes out. So we're not going to touch this. We're going to take this to the power of 2, becomes x squared minus 2xc or 2cx and plus c squared, and this remains unchanged. And we're going to multiply everything by a squared. So we get a squared x squared minus 2c a squared x in any format. And this was c squared, so a squared c squared. This one is y squared, becomes a squared y squared. And again, we look at both sides. We notice these two are identical, so we can drop it. We can move this to this side. We can move this to this side. So notice what's going to happen. The left side is a to the power of 4 minus a squared c squared. And the right side, basically, these two remain, and this takes a negative sign. Why do we do that? On the left side, we can factor out the a squared. On the right side, for these two, we can factor out the x squared. And now we're going to make this into 1. Remember, a and b and c, they are constant, so we're going to divide both sides by this. We are dividing both sides by a squared times a squared minus c squared. We divide both sides by the left side. When you divide by the left side, this one is the one. This one, a squared minus c squared goes over, you get x squared over a squared. And this one, a squared goes away, you get y squared over a squared minus c squared. So we divided both sides by the left side. We also know a squared plus b squared equals c squared. So this is a squared minus c squared. So if you work on this, a squared minus c squared becomes minus b squared. And that's exactly what we get here. And this makes this fraction negative. So x squared over a squared minus y squared over b squared equals 1. That is the proof. Pretty straightforward, everybody. So that's a proof. Again, you're not responsible for the proof. If you can follow it, it really would be nice. You are in good shape. All right, we want to graph hyperbola. So determine the equation of the asymptote of the hyperbola and graph. So first, let's analyze the graph as we look at this and we compare it to the first one. We notice a squared is 9, b squared is 16, which makes a is 3, b equals 4. So analyzing and comparing it to this one. And so it is centered at 0, 0. Because x squared over 9, this is positive, then the vertices are at plus minus 3, 0. In other words, the transverse axis is along the x-axis, and we plot those pairs. Since y is plus minus b over a times x, we have plus minus 4/3 x. So we have 4/3 x as well as negative 4/3 x. And you can graph those two lines easily. The fundamental rectangle has the following vertices. Because it's centered at 0, 0, it's plus minus a plus minus b. That creates the following 4 pairs. Remember, a is 3, b is 4. So negative 3, negative 4, negative 3, positive 4, positive 3, negative 4, positive 3, positive 4. That's what it creates. Okay, and those are helpful. And those are the two asymptotes. And remember, it opens sideways. So that's the graph. Now, for the analysis, let's find the value of c. We know a squared plus b squared equals c squared. And over here, we had a squared and b squared already. So 25 makes c 5. And therefore, foci are at plus minus 5 and 0. So it makes c equal to 5. So that's a complete graph with details, with asymptotes, with fundamental rectangle, with vertices, center, and foci. These are the foci class. You don't have to plot those pairs. I just wanted you to see what happens as far as the rectangle is concerned. Let's look at another example. Determine the equation of asymptote of the hyperbola and graph it. Again, we're going to compare to that. And you notice that a squared is 25, b squared is 49, which makes a equals 5, b equals 7. Again, it is centered at 0, 0. Because this has a positive coefficient, then here's the transverse axis. We have the vertices at plus minus 5, 0. So 5 to the left, 5 to the right of the center. And the equation of asymptotes plus minus b over a plus minus 7 over 5 x to help us graph the fundamental rectangle. Because it's centered at 0, 0, we get the same thing, plus minus a plus minus b. That means plus minus 5 plus minus 7. And that means negative 5 and negative 7, negative 5 and 7, positive 5 and negative 7, positive 5 and positive 7. And these are the 4 corners, everybody, which will help us. And these are the 2, if you were just looking at the concept of 0b and 0 negative b. And here's your asymptotes. And here's your graph. So again, look at the 4 corners that we mentioned. And again, a squared plus b squared equals c squared. So that means 25 and 40, and 9 is 64, and c becomes 8. Therefore, plus minus 8, comma 0. And so it may not be to scale, but you know, this should be sort of here. So 8, 0 and negative 8, 0. I mean, you can write. Graph the hyperbola of y squared over 16 minus x squared over 1 equals 1. Also show the fundamental rectangle with its corner points labeled the asymptotes and the intercept. Analyze the graph. Now, a couple of things I want to mention. First of all, the y squared has a positive coefficient of 1 over 16, which makes this time following this one, okay? And so in this case, a squared is 1 and b squared is 16. Now, one thing I want to add, they don't have to write x squared over 1. You have to recognize it's x squared over 1. In other words, most of the time they would write it as follows. They would write this as y squared over 16 minus x squared equals 1. And you should recognize when there is no denominator, the denominator is 1. So a is 1, b is a 4, and we have the same center, 0, 0. However, this opens up and down. The transfer axis is no longer the x, but rather the y-axis. And so we have the vertices at 0, 4, and 0, negative 4. So this is the center. Here's the vertices. So that's the difference, basically. And again, as I mentioned, I like to keep the b squared under y squared, okay, and a squared under x squared. That's not how they do it in many texts. So just understand the concept. And so when I keep it in this format, this formula doesn't change. Plus minus b, which is 4 over a, which is 1, x, so plus minus 4x. And again, you can graph those. Remember, of course, one pair for both of them would be 0, 0. And then, for example, here, if you choose x equals 1, y becomes 4, and you can take it from there. The fundamental rectangle, again, has the same corners, plus minus a, plus minus b. That means negative 1, positive 4, negative 1, negative 4, and then we go with 1, negative 4, and 1, positive 4. So we make up those 4 points. Those are the asymptotes. And those are, again, the points that are really part of that. You know, this is a0 and 0. It's not vertices, nothing. but because we know the relationship between a squared and b squared is that a squared plus b squared equals c squared, which makes it 17. So c is square root of 17. So the foci, now here's what's interesting. The foci is no longer on the x-axis, on the y-axis in essence. So it's at 0 plus minus square root of 17. And for the sake of graph, if we go with the decimal representation, roughly 4.1, it's located at 0, negative 4.1, and 0, positive 4.1. Again, exact answer, a rough estimate for the sake of graph. So basically, we understand the differences, the way they open up. Finding an equation of a hyperbola. So what is given? Find an equation of hyperbola having one vertex at 0, 2, and foci at 0, negative 3, and 0, 3. Because of the way it's given, clearly it is giving us the center, because the center is between these two, by the way. So this tells us the center is 0, 0. This tells us B is 2. This set also tells us C is 3. And again, as I said, the center at 0, 0. So from these two pieces of information, we get these two pieces, we get three pieces of information. We get the center, we get the value of B, we get the value of C. And remember, this is going to open up and down. Again, we have done the graph already, so I'm going to do the graph at the end in one shot, but I just want to, analyze that. You can graph the center 0, 0. You can graph the vertex at 0, 2, and 0, negative 2. So the vertices, so 0, 0 go up and down by 2 units. Those are the vertices, and 0, 3, and 0, negative 3 are the foci. Now, we know a squared plus b squared equals c squared. We have the b, we have the c, and a is missing. This is 4, this is 9. A squared is 5, or a squared of 5. So we are going to use this equation, and we're going to write y squared over b squared minus x squared over a squared equals 1, which results in y squared over 4 minus x squared over 5 equals 1. The fundamental rectangle remains the same, plus minus a plus minus b. That means plus minus square root of 5 and plus minus 2. So these are the pairs. And here's the graph. I'm going to assume you know how to graph it by now. Again, here's the x, here's the y-axis, here's the transverse axis, here's the center. Here's the vertices at 0, 2, and 0, negative 2. Here's the focus 1, 0, 3, focus 2, 0, negative 3, or focus 1 here, focus 2 here. Here's the graph, and we do have the, I'm going to leave it for you to draw the fundamental rectangle as well as the asymptotes. We want to analyze this equation, 9x squared minus 4y squared equals 36. We've seen it when we dealt with ellipses. To put it in a format we are familiar with, the standard form, we divide by the constant, which is 36. We're going to divide both sides by 36. So this becomes x squared over 4 minus y squared over 9 equals 1. So let me just put the 36 here. So you divide by the constant, which is the right side. If it's not, you put it in that format. Again, we want to analyze the equation. I'm going to assume you know how to graph this. Understand a couple of things. A squared is 4, b squared equals 9. So A is 2, B is 3, which makes, of course, the weights given the center is at 0, 0. So everybody can grab the 0, 0. And this opens sideways, so we have it at plus minus 2, 0, the vertices. The equation of asymptote plus minus b over a x plus minus 3 halves x. So we have 3 halves x and negative 3 halves x. And we can, again, use a couple of pairs for those. Or just remember, because the center is located at 0, 0, then we have plus minus a plus minus b. That means plus minus 2 and plus minus 3 as the corners. And if we were to find the foci, a squared plus b squared is c squared, and we have 4 and 9 is 13. So we have plus minus square root of 13, 0. This is an approximation. And here's a graph with details, again, centered at 0, 0. These are the vertices at 2, 0, negative 2, 0. Those points are helpful, and they will give us the fundamental rectangle. The diagonals on the fundamental rectangles, they give us the two asymptotes. So one more time, one thing that is important to understand. What does fundamental rectangle do for us? If you draw their diagonals and you continue, it becomes the two asymptotes. And the location of F1 and F2, about negative 3.60 and positive 3.60. So we got all the information, and that's the synopsis of what we had to do. Graphing a hyperbola with the graphing calculator, we've already discussed it with the elliptical shape as well. You have to solve for y if you want to use a graphing calculator. So to do so, we are going to move the negative 4x squared becomes positive on the other side. And if you take a root of both sides, this becomes 5y, this becomes plus minus the square root of that. Now you divide both sides by 5. You get plus minus 1 over 5 squared of 9 plus 4x squared. When you put it into a calculator, you put the positive 1 as y1, negative 1 over 5 squared of 9 plus 4x squared as y sub 2. And it gives you the top halves. Positive y1 is 1/5 squared of 9 plus 4x squared. And the bottom piece is negative 1/5 squared of 9 plus 4x squared. I just wanted to mention, and I've shown you that one with respect to an ellipse. You have to solve for y, and it gives you two pieces. Because remember, this is not a function. Now, what happens when we have a different center, okay, H and K, looking something like this, where we have moved the center to H and K, or this one, or for that one. So it does have an effect on everything as far as the equations are concerned. First and foremost, we have x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. This gives us the center at h and k. If it opens sideways, if it opens up and down, now we have y minus k squared over b squared minus x minus h quantity squared over a squared equals 1. Again, notice I keep the a squared under x, same thing here. When we do that, the equation of an asymptote remains the same. So we just look at this as an asymptote and we make the change with h and k as follows. Y is, instead of y, we're going to put y minus k. Instead of x, We're going to put x minus h. Of course, class, we know it becomes y equals plus minus b over a times x minus h plus k. We know that. But why did I give you in this format? It's easier to memorize it because you know this formula, y plus minus b over a times x. So replace the y with y minus k and the x with x minus h. Then you can, distribute and simplify and combine like terms if you want. So graphing a hyperbola translated from the origin. So this is the basic one. Now the transformation. And so in this case, we have a y plus 2 quantity squared over 9 minus x plus 3 quantity squared over 4 equals 1. Clearly, we can see the center is at -3, -2. A squared is 4, b squared is 9, because we are going to compare it to this one with me. So we have 3 pieces of information, the center, a squared, and b squared. So this hyperbola has the same graph as if you didn't have the different center, as y squared over 9 minus x squared over 4 equals 1, except that it is centered at -3, -2. So if you graph this one and shift it by this much, you get the same thing. Okay. That means 3 to the left, 3 units to the left, 2 units down. That's the meaning of this. When the center is this, that means 3 units to the left, 2 units down. All right, so a squared is 4, b squared is 9. It makes a2, b3. And as I mentioned, the center is given. Now, since this opens up and down, because y squared in essence has a positive coefficient, it opens up and down. So in order for you to find the vertices, you go back to the center and you go up and down, by how many units? By b units, which happen to be, this is the center, -3, -2, and the vertice is up and down by b, which is 3 units, b or 3 units. So that means the y coordinate here, we're going to add and subtract 3. So when you subtract, you get -5. When you add, you get +1. So you locate those pairs. So those are your vertices. We're going to go with this formula. Y minus k plus is equal to plus minus b over a times x minus h. So instead of this, we're going to put y plus 2 plus minus b is replaced by 3, a is replaced by 2, x minus h is replaced by x plus 3. Just in essence, put this parenthesis here, put this parenthesis here. It's that simple. Now, I'm going to assume you can distribute the 3 halves, and then you move the 2. The right side here is plus minus 3 halves x plus minus 9 halves, and you move the 2, and remember, because you have the 2 as the denominator, you change the 2 to 4 halves, and it results in -3 halves. If it's -9 and -4 is -13 halves. If it's +9 and -4 is +5 halves. This is how you get this, and this is -3, everybody. Now, the fundamental rectangle has vertices at uh, A units to the right and left of the vertices. So wherever the vertices are, here's the vertices. Look at A and go A units to the right and left, A units to the right and left. Okay. So for the sake of argument, if you look at this one, -3 -5, if I go to the right by A units, gives me this point, -1, -5. I'm talking about this point, my apologies, -1, -5. This one, -3, 1, when I go to the right by 2 units, gives me -1, -1. So 2 units to the right of this, 2 units to the right of this, and then left and left. So we end up with the following, looking like that. Drawing the two asymptotes and the graphs, and we are done. Write the equation of the hyperbola in standard form. Identify the coordinates of the center, the vertices, foci, and the equation of asymptotes. Graph the hyperbola. So the main thing is to rewrite it such that it's in standard form. So what do? We put all the x's together, all the y's together, and we make sure 43 on the other side. And these two, we can take out number 9. So let me actually do this first. And then, so this one, I can take out 9 times x squared minus 2x. Use a different color of that. These two, I can take the -4 out. I get y squared plus 4. Now, we're going to use completing this square. Please understand b is -2. Let's just write this. I'm going to write it with the blue. For the blue part, everybody, and then I'm going to erase it. B is equal to -2. Divided by 2, you get -1. Square it, you get +1. So we need +1 for that. For the red one, b is 4. Divided by 2, you get 2. Square it, you get 4. That means we need to add 1 for this one, which means you're adding 9 times 1, and you add it to both sides. You need to add 4 this one. That means you're adding -4 times 4. That means -16. So again, when you add 1 here, you add 9 to both sides. When you add 4 here, you're adding -16 to both sides. That's the concept. Okay, let me erase my work so you can see that. thought I put 60. So 43 plus 9 minus 16. That means 52 minus 16 or 36. On the left side, we have 9 times x minus 1 quantity squared minus 4 times y plus 2 squared. And we are going to divide both sides by the constant on the right, meaning we're going to divide by this number. So we get x minus 1 squared over 4 minus y plus 2 quantity squared over 9 equals 1. And now, obviously, this opens sideways because it looks like that. A squared is 4, b squared is 9, centered at 1, negative 2. A squared is 4, that means a is 2, b squared equals 9, that means b is 3. It's centered at positive 1, negative 2. And as we said, it's going to open sideways. The transverse axis is parallel to the x-axis. So we go back to the center. And from the center, we go a units to the right and a units to the left to come up with the vertices. So as we do that, 1 plus 2 makes it 3, 1 minus 2 makes it negative 1. So this is the center. And these are the two vertices, 3 minus 2, negative 1, negative 2. Asymptotes, y plus is equal to plus minus b over a, 3 over 2, x minus h, x minus 1. Okay, and remember, this is y minus k, which was y plus 2. So we have y plus 2 moves to the other side, becomes negative. That's the equation. And again, I'm going to leave it for you to simplify it. There are two equations here, class. And so those are the two lines. And the fundamental rectangle has vertices at b equals 3 units above and below of vertices. It has four, those are the vertices, those are the 4 corners, the 4 points. Okay. And so what happens, wherever the vertices are, you go up and down by b units. So we are going to go, for example, to this number, add 3 and subtract 3. And so we have those 4 points, and it looks like that. And here's the graph. And to find the foci, we know a squared plus b squared equals c squared, which makes 4 plus 9 equals 13. And therefore, c equals square root of 13, everybody. So we go back to the center, and we go c units square root of 13, everybody. We go back to the center, c units to the right, that means add to 1, and c units to the left, that means subtract from 1. So we get 1 plus minus square root of 13 minus 2. Now, to show that, we go with an approximation, and we get 1 minus square root of 13 is about negative 2.6, and 1 plus square root of 13 is about 4.6, and they both have the same y coordinate, namely negative 2. And that's the detailed graph of this hyperbola.